In this lesson, we want to continue to talk about the properties of matrices. And specifically here, we're going to talk about adding and subtracting matrices. All right, so we're going to begin our lesson with the addition of matrices. First and foremost, we can only add two matrices together if they're the same size, or again, as we talked about in the last lesson, the same order. So these are the kind of dimensions of the matrix. It's how many rows you have by how many columns you have. So for example, if we had a 3x4 matrix, that matrix has 3 rows and 4 columns. And if you had two 3x4 matrices, you could add those two together. Okay, that would be perfectly fine. But if you had a 3x4 matrix and you had a 2x3 matrix, you couldn't combine those two with addition. That operation would be said to be undefined. So the first thing you would do is verify that, again, they're the same size or order. Once that's done, then you can simply add the two matrices together by adding the corresponding elements. It's actually a very easy process overall. So suppose I have matrix A, and matrix A is equal to, in the first row we have the elements 3 and -1. In the second row we have the elements 5 and 2. Then suppose I also have this matrix B, and in matrix B, we say this is equal to, in the first row, -4 and 3, in the second row, 1 and 7. So in each case, I have 2 rows and 2 columns, so they're each going to be a 2x2 matrix, so I can find the sum of A and B. So to do that, if I want to find the sum of A plus B, it's just equal to what? Well, I'm just going to sum the corresponding elements. So all that means is I just take the element in the first row in the first column, okay, and the element in the first row in the first column in each case, and I find the sum. So what is 3 plus -4? Okay, we'll do that in a minute. And then we just go through and do the same thing for kind of each case. So here I would have -1 plus 3. So -1 plus 3. Then down here I would have 5 plus, over here I have a 1. Then I would have a 2 plus a 7. Okay, so that's all you're doing. You're just adding the corresponding elements from the two matrices. All right, so let's crank this out real quick. So we know that 3 plus -4 would give us -1. Let me kind of slide down a little bit. So I'm just going to say this is going to be -1. Then down here, 5 plus 1 is going to give me 6. And then -1 plus 3 is going to give me 2. And then 2 plus 7 is going to be 9. Okay, so this is the matrix that is the result of adding A plus B. In your top row, you'd have -1 and 2. In the bottom row, you'd have 6 and 9. All right, let's take a look at another example. So suppose now you have this as your matrix A and this as your matrix B. So if I want to find the sum of A plus B, okay, first and foremost, I've got to verify that the order is going to be the same in each case. So we see that for matrix A, I have 3 rows and 3 columns, so it's a 3x3. And for matrix B, it's 3 rows and 3 columns, so again, it's a 3x3. So because they're the same size or the same order or they have the same dimensions, however you want to say that, we can add them together, right? We can find the sum. So again, to do this, it's very simple. I just add the corresponding elements. So if I start up here in row 1, column 1, I add those two guys together. And I'm just going to do this right here. I don't need to write it out. So -2 plus -1 is going to be what? That's going to be -3, okay? Then let me erase this and I'll highlight each one that I'm doing. So let's do this one now. So what is 1 plus 6? That's going to be 7. And then what is 7 plus 2? That's going to be 9. Okay, so that's my first row. That's done. So now let's move on here. And I'll just do these a row at a time now to make it a little bit faster. So what is 5 plus 8? That's going to give me 13. What is 6 plus 3? That's going to give me 9. What is 9 plus 4? That's going to give me 13. And then let me erase this. We'll go to this bottom row. So this and this. We'll say what is 1 plus 11? That's 12. What is 4 plus -6? That's going to be -2. And then lastly, what is 8 plus 10? That's 18. Okay, so this matrix here is the sum of the matrix A plus the matrix B. All right, now you can also add more than two matrices together. Again, they've all got to be the same order or the same size. And in this case, we have a matrix A, a matrix B, and a matrix C. And we're going to find the sum. So in each case, we have 1, 2, 3, 4 rows and 1 column. So they're going to be a 4x1 matrix in each case. And remember, in the last lesson, we said that these were a column matrix, right? Because there's only one single column. So to add these together, we do A plus B plus C. I want to just note here that the commutative property that we learned with addition of real numbers would hold here. I can add these in any order. Also, the associative property, right? I can group the addition however I want. It won't change the sum either way because all I'm really doing is I'm adding things together. And with addition, we know that it's commutative. We know that it's associative. So nothing's really going to change the sum. So let's go ahead and set this up. So I'll just do this like this. And again, I'm just going to work here. I'll do 3 plus -2 plus -8. So 3 plus -2 is 1. 1 plus -8 is -7. Let me move down to kind of the next row. I'll do 5 plus 9 plus 14. 5 plus 9 is 14. 14 plus 14 is 28. And then let me move down to this row here. And I'll erase this one up here. So now I'm going to do -7 plus 3, which is going to give me -4. And then -4 plus 6 is going to give me 2. And then lastly, I'm going to have this bottom row. So I'm going to have 10 plus 1 plus 9. We know that 9 plus 1 is 10 and 10 plus 10 is 20. Okay, so pretty easy overall. So A plus B plus C is going to give us this matrix that's still a column matrix, right? It's got the same dimensions as what we were adding. And we got -7, 28, 2, and 20 as that column there. Okay, so 4 rows, 1 column. It's still a 4 by 1. All right, so let's move on and talk about subtracting matrices now. So again, when you subtract matrices, it's the same thing. You have to have 2 matrices with the same order, or again, same size or dimensions, whatever you want to say. In this case, we're going to start out with A, which has the elements 5, 1 in the first row and 9, -5 in the second row. And then B, which has the elements 7, 2 in the first row and -9, 12 in the second row or the bottom row. So each of these is a 2 by 2 matrix, right? 2 rows and 2 columns. Now, if we subtract, it's not commutative, right? We have to know that A minus B is not going to be equal to B minus A. You can kind of eyeball this and see that if I did, let's say this guy right here, so this 5 that's in row 1, column 1, and this 7 right here that's in row 1, column 1. If I did matrix A minus matrix B, well, 5 minus 7 would give me -2. If I did matrix B minus matrix A, well, 7 minus 5 will give me +2. Those two elements wouldn't end up being the same, so those two matrices would not be equal, right? So A minus B would not be equal to B minus A. So for the purposes of what we're going to do here, I'm just going to do A minus B. And again, it's a very simple process. I'm just going to match up corresponding elements, and I'm going to do my subtraction in the correct order. So if I have A minus B, I'm going to take the element in matrix A and subtract away the corresponding element in matrix B. So in this case, I'm going to do 5 minus 7. Again, this is in A, this is in B. I'm going to do 1 minus 2. Okay, I'm going to do a 9 minus a -9. Be careful there because you have a negative there. Okay, so 9 minus -9. And then I'm going to do -5 minus 12. Okay, so 5 minus 7, we know that's -2. Okay, so this is going to be -2. And then 1 minus 2 is -1. 9 minus a -9 is 9 plus 9, that's 18. And then if we had -5 minus 12, that's -17. Okay, so this would be the result of A minus B. Now, there's another way to do this, and this is probably what you're going to see in your textbook. I want you to remember that when we subtract integers, right, we learned that we could do A minus B, and I'm just using A and B as any real numbers. And this might get confusing, so let me use P and Q. So P minus Q. P is a real number, Q is a real number. We can say that P plus -Q is the same thing, right? So if I had 5 minus 3, I could write this as 5 plus -3, okay? So we're going to use that same concept here, and we can say that if I have matrix A minus matrix B, I can say this is A plus the negative of B, okay? And we haven't talked about multiplication yet with matrices. We'll get to that in the next lesson. But essentially, if I have the negative of B, I can just go into my matrix B, and I can change the sign of every element, okay? It's just like multiplying every element by -1. So let's go ahead and set this up real quick. Let's say that we have the negative of B, and I'll say this is equal to what? Instead of 7, I'll have -7. Instead of 2, I'll have -2. Instead of -9, I'll have +9. And instead of 12, I'll have -12. Now what I can do is I can say, let me make a little border here, A minus B. Okay, so A minus B is equal to A plus the negative of B. So this will be equal to, let me set up this matrix. I'm going to say 5 plus this guy right here, because I'm working with negative B. So 5 plus negative 7, okay? And then I'd have 9 plus 9, so 9 plus 9. I would have 1 plus negative 2, so 1 plus negative 2. And then I would have negative 5 plus a negative 12. Now, because I switched this operation from subtraction to addition, once I'm adding the opposite, once I have this set up, I can add in any order, right? If I do negative 7 plus 5, or if I do 5 plus negative 7, I get the same answer. But you can only do that once you've changed it into its opposite and you've set up the addition, okay? So don't make that mistake. You can't do that with subtraction. All right, so let's go ahead and crank this out. So 5 plus negative 7, again, we know this is going to be negative 2. 9 plus 9, we know that's 18. And then 1 plus negative 2, we know that's going to be negative 1. And then negative 5 plus negative 12, again, we know that's negative 17. So it's the same answer. It's just a different way to kind of look at it. This might be easier for you. It might be harder for you. It doesn't matter. You get the same answer either way. So whatever you want to use. All right, let's take a look at one more example with subtraction. So suppose we have A and we have B, and we want to subtract, let's do B minus A this time. So B minus A. Okay, so I'm not going to go through and say B plus negative A. You can do that if you want. Again, it's the same answer. I'm just going to save time and do B minus A. Okay, so what I'm going to do, because these guys, again, are the same size, this is a 1, 2 by 1, 2, 3. So it's a 2-row and 3-column matrix in each case. So it's a 2 by 3, so we can subtract them. I'm going to do each element of B minus each corresponding element from A. So 5 minus a negative 1, 5 minus a negative 1, and let me change colors. We would have 1 minus 8, 1 minus 8. We would have negative 2 minus 2, okay? And then, let me change colors again. We'd have negative 4 minus 11, and then we'd have 9 minus 14, okay, 9 minus 14. And then we would have 15 minus 6. All right, so 5 minus a negative 1 is like 5 plus 1, so that's going to be 6. Then 1 minus 8 is going to be negative 7. Then negative 2 minus 2 is negative 4. And then negative 4 minus 11 is negative 15. So negative 15. And then 9 minus 14 is negative 5. Okay, so that's negative 5. Then lastly, 15 minus 6 is going to be 9. So this is the result of B minus A. Again, if you wanted to, you could do B plus the negative of A. So to do that, you would change each element inside of this matrix A into its opposite, and then you could add and you would get the same result. All right, so now let's talk about the kind of zero matrix. This is a matrix that is also referred to as the null matrix. It's a matrix that contains only zeros as its elements, okay? So the zero matrix can be written as any size. So whatever size you kind of need to work with, you can make a zero matrix to kind of work with it. So if you need a 2 by 3, a 30 by 30, 715 by 220, you can do whatever you want. It's all going to be zeros. Now, generally speaking, we're going to notate this with a 0. At least that's how I'm going to notate it. A lot of books do different things here. You might see a 0 with kind of the size. So in this case, I have 1, 2, 3 rows and I have 2 columns. So you might see them write a 0 and then say it's a 3 by 2, okay? If it's known what the size is, you typically just put a 0 instead of writing out all these zeros. But there's other notations that you might come across. They might use a letter to represent this. So just stick to what your book gives you. Now, I want you to recall that when we worked with kind of real numbers, we said that 0 was the additive identity. And what that means is that if I add 0 to something, it's unchanged. So if I use P or Q again, let's just use Q, and I add 0 to that, I'm going to get Q back. Okay, Q is just some real number. So for example, if I had 111 and I added 0, I get 111, right? If I had a trillion and I add 0, I get a trillion. So 0 is the additive identity. Well, when we do matrix addition, because a zero matrix only has zeros as its kind of entries, what happens is every time you add the zero matrix to another matrix, you just get the original matrix back. So the zero matrix is the additive identity in matrix algebra. So for example, here, if I add A plus this 0 matrix, I'm just going to put a 0 there, okay? I'm just going to get A back. Because all I would be doing is saying that I would set this up and say, let me kind of do this. I would do 5 plus 0, which is 5. I would do 2 plus 0, which is 2. I would do 1 plus 0, which is 1. I would do 7 plus 0, which is 7. Let me make this a little bit longer. I would do 8 plus 0, which is 8, and negative 4 plus 0, which is negative 4. So I get A back, right? This is equal to A. I haven't changed anything because in each case, I just added a real number to 0, and so I got that real number back. All right, now additionally, we saw that if you added a real number and its additive inverse together, you got 0. Okay, so it's going to be the same thing or the same concept when we work in matrix algebra. If we have some matrix A, okay, and we add to it the opposite or the negative of A, you're going to end up with a 0 matrix. So in other words, if I have this matrix A and I have these entries here, 3, negative 5, 8, 11, and then 6 and 4, I could say the negative of A is what? We talked about this earlier. I'm just going to multiply each kind of entry here by negative 1. So this would be negative 3. This would be negative 8. This would be negative 6. This would be positive 5. This would be negative 11. This would be negative 4. Okay? So what happens is if I add A plus negative A, I'm going to end up with a 0 matrix. And in this particular case, I'm going to have a 0 matrix that's what? It's 1, 2, 3 rows by 2 columns, right? So it's a 3 by 2. You could write that if you want, or again, it's going to be obvious that it's a 3 by 2. So you can just leave that 0 as the notation. And again, you can go through and kind of crank this out to prove it. 3 plus negative 3 is 0. Negative 5 plus 5 is 0. 8 plus negative 8 is 0. 11 plus negative 11 is 0. 6 plus negative 6 is 0. And 4 plus negative 4 is 0. So again, you end up with this 0 matrix. And instead of writing all this out, you just put a 0, okay, to notate that you have a 0 matrix. All right, so let's wrap things up with an introduction to matrix equations. This is something we're going to be dealing a lot with kind of in this chapter and also as we progress in math in general. So with a matrix equation, we have an equation where variables are used to represent matrices. So at this level, it's very, very simple. Let's say I have a matrix A and a matrix B. They're both a 2 by 2 matrix, so we know we can add them together. And we have matrix A plus this matrix X, which we don't know what that matrix is, and we say it's equal to this matrix B. So if I want to solve for X, I can use the same strategies that we talked about when we solved linear equations here. Okay, so I can subtract matrix A away from each side of this equation, and I can say that the matrix X is going to be equal to the matrix B minus the matrix A. Okay, so you see where we're going with this. We can find out what X is by just doing B minus A. Okay, so what is, let me kind of make a little border here. What is B minus A? That would be equal to what? Well, I would just take each element from B and subtract away the corresponding element in A. So 4 minus 2 would be 2. Negative 1 minus 8 would be negative 9. Okay, 5 minus a negative 1 is like 5 plus 1, so that's 6. And then 9 minus 3 would be 6. So this is B minus A, and it's also equal to X because we said X was equal to B minus A. So let me just write here that this is equal to 2 and negative 9 for the top row, and then 6 in the bottom row. And you can check this. That's the good thing about kind of working with equations. You can always check. Well, if it's true that the matrix X, which is this guy right here, is equal to the matrix B minus the matrix A, well, then it's also true that A, this matrix here, plus X, this matrix here, would give me B. You can check that really quickly. You can say, okay, if I had 2 plus 2, would I get 4? Yeah, that's a check. If I had 8 plus negative 9, would I get negative 1? That's a check. If I had negative 1 plus 6, would I get 5? That's a check. If I had 3 plus 6, would I get 9? That's a check. So our matrix X is this guy right here, right? With 2 and then negative 9 in the top row. And that kind of looks like 2 minus 9. So let me make that a little bit cleaner. And then 6 and 6 in the bottom row. All right, let's try one more of these, and then we'll just kind of call it a day on this. And in the next lesson, we'll look at some matrix multiplication. All right, so we have our matrix A, our matrix B. Again, they're the same size. In each case, we have a 3 by 3, 3 rows, 3 columns. So we have that A, this matrix here, plus X, which is our unknown matrix, is equal to B, which is this matrix here. So again, I'm just going to solve for X. I'm going to subtract this matrix A away from each side of the equation. And And again, we find that x is equal to b minus a. And I don't need to check this time. We'll just crank this out real quick and call it a day. Let me kind of slide this over a little bit. And so what is b minus a? So again, we have 12 minus the negative 1, which is going to be 12 plus 1, which is 13. Okay, and then we have 11 minus 5, which is 6. We have 8 minus 9, which is negative 1. We have 10 minus 2, which is 8. We have negative 6 minus 7, which is negative 13. We have 5 minus the negative 1, which is 5 plus 1, that's 6. We have 13 minus 15, which is negative 2. We have negative 9 minus 13, which is negative 22. And lastly, we have 4 minus the negative 3, which is 4 plus 3, which is 7. So x, our matrix that was unknown, again, is equal to the matrix B minus the matrix A, which gives us this matrix here. Again, in the top row, you have 13, 6, and negative 1. In the middle row, you have 8, negative 13, and 6. And in the bottom row, you have negative 2, negative 22, and 7.